30th, 1968, first giant 747 is presented to the world. This is a milestone in Boeing history, a time to look forward and a time to look back. To the beginnings, May 1966, a tranquil woodland near Everett, Washington, swept clean to make room for a new dimension. A factory, the world's largest, takes form. Inside, the 747 program becomes a reality, from paper to metal. Machining and manufacturing. Assembly and major body joints. The airplane grows. Rollout marks the beginning of a new phase. An exhaustive program by test engineers. Their goal, to ready the huge airplane for her maiden flight. Every system and subsystem installation is checked. Every coupling, component, and calibration is scrutinized. Followed by an engineering safety inspection. On hand are all echelons of management, engineering, manufacturing, and safety for a total airframe and power plant examination. All 53 movable surfaces are checked and timed. As is the 16-wheeled main gear. Outdoors again. The plane is rotated on air cushion platforms while the compass system is checked. In spite of snow and freezing temperatures, engines are motored. Then run up and trimmed, equalized thrust from all four engines at identical throttle settings. Now the flight crew takes over, feeling out the steering in a series of tight turns. Taxi tests are run and rerun, establishing braking and thrust reverser characteristics at speeds from 80 to 140 knots.
During the taxi tests, which included some fairly rigorous high-speed tests up to 165 or so. We had the nose in the air about 9 degrees, a few more knots, so we'd have been airborne prematurely.
February 8, 1969. The dress is informal, but the occasion is not. Top Everett manufacturing personnel gather in a control room to release the 747 to flight test. Jack Waddell, chief test pilot, formally accepts the airplane. After the ceremony, the flight crew makes one last check. Computers to measure and record first flight data. Ballast. Instrumentation. It is the day before first flight and a new dimension in air travel. February 9th, approaching takeoff time. The flight crew moves out to the waiting airplane. Pilot Jack Waddell. Co-pilot Brian Weigel. Flight engineer Jess Wallach. Takeoff requires only 4,300 feet of roll. Gross takeoff weight is 467,500 pounds. Each engine producing just under 39,000 pounds of thrust.
Hey, Paul, let me know when to release brakes. Hey, you release brakes any time, I can pick up. Okay, you're just spread them around for me, Brian. Watch those steps. I want to watch these things. We've got a lot of ways, long ways to go. Now, you take it. I'll watch it. 70 knots. Yeah, good. 90 knots. I'm off to steering. Let's go power. Let's get everything. Looks good. We are. Okay.
Turbulence. The old girl soaks that turbulence up very nicely. Turn coordinator is working, doing its job normally, apparently, and the aeroplane is just excellent. Okay, we're breaking out into very nice weather now. It's ridiculous. It's a very easily flyable airplane, though, and it doesn't want a Dutch roll. Still in the takeoff configuration. We haven't tried to change anything yet.
Everything looks very normal on the right side, Jack, and gear doors look closed, and I'll go over and check the left.
Beautiful.
Everything looks very normal on the left side, Jack.
Very good.
One thing I've noticed throughout the whole flight, I've never seen any black smoke come out at all. You can't tell from outside if the engines are running or not.
They're clean, all right. They are on the ground as well.
In the final approach, basic airspeed is 140 knots. Landing weight, 440,000 pounds.
During the landing approach were almost unbelievable in that the airplane sits there like a stable platform. The pilot has to keep telling himself, and I'll leave it alone, it doesn't need any help here. We just got it pointed and the airspeed adjusted, and we let it just drive right on in and land, almost land itself, literally.
Radio car, you want to take a look at our cars before we go in, please?
Roger, will do. Okay, we counted them. You got 16 under there.
The height associated with this large airplane during takeoff and landing, boy, this seems the way an airplane, this way it should look out of the cockpit.
You have to help me hold them all. Somebody get it. Hi, Al. Jack, how are you?
Good.
Well, first things first, isn't that correct?
Good, always, right.
Okay, Jack, natural question is, what are your impressions?
Well, Al, I guess this sounds complacent or something, but that thing is just ridiculously easy to fly. It's just a pilot's dream. Really a nice airplane to fly.
Welcome aboard the Boeing 747, the world's largest commercial jet transport. This airplane was developed by confidence and skill. We furnished the skill, and our first customers provided the confidence. Confidence in Boeing's capabilities, and confidence enough to place orders before the airplane was built. To acquaint you with the 747, let's first discuss size. The airplane is 231 feet long, the passenger cabin is 20 feet wide, and the wingspan is 195 feet 8 inches. The 747 has a fuel capacity of over 47,000 U.S. gallons. 3 models of the 747 are available. The passenger version that we are discussing today, the 747C, or convertible model, and the 747F, or freighter. All 3 were developed around one basic airplane. 3 compartments beneath the main deck are used to carry baggage and cargo in containers. Capacity is over 30 tons. Loading the containers is a mechanical function requiring only one operator. Sitting up topside, the pilots have an almost unobstructed view. Windows are larger than those on earlier transports, and the cockpit arrangement provides for maximum crew efficiency. And way back in the tail section is an auxiliary power unit made by the Garrett Air Research Corporation. The APU is used to start engines and to supply power for lights and air conditioning while the airplane is on the ground. The four engines that power the 747 are built by Pratt & Whitney. They are the JT9D high bypass ratio fan jet engines. Each produces 43,500 pounds of thrust. The JT9D is quieter than engines that power today's transports, and because of complete combustion, it produces virtually no smoke. Computers were used extensively in designing the engine. High strength-to-weight titanium alloys permitted drastic weight reduction over earlier engines. And the elimination of guide vanes ahead of the inlet fan solved the problem of high-frequency whines associated with jet aircraft today. Now let's look briefly at some of the highlights of the 747 program, the planning and development that made this airplane possible. Design objectives included high-speed cruise, low operating costs, reduced noise, and the capability of using existing runways, and these objectives have been met. We examined many possible designs before finalizing the 747. At one time, the airplane was a mid-wing with 2 decks, then a low wing with 2 floors. At one point, the pilot's cockpit was located below the passenger cabin. But finally, after months of study and exhaustive discussions with the airlines, the 747, as you see it today, was determined to be the most efficient design from the point of view of comfort, performance, and profit potential. Because the 747 is nearly 9 feet wider than its predecessor, the 707, the cabin could be designed for maximum comfort and passenger appeal, with seats 10% wider than those of the earlier transports. 10 double-width doors provide easy loading and unloading. 5 cross aisles and 2 longitudinal aisles make it possible to reach all areas of the cabin comfortably. The passenger service units, located overhead and along the side walls, provide room for stowage of small articles, and headroom in the 747 is much greater than that of earlier airplanes. In-flight food and beverage service is taken care of by numerous galleys, located strategically along cross aisles. Now let's look at a few important design features. The triple-slotted trailing edge flaps used during takeoffs and landings represent a marked advance in aircraft design. Extension of the flaps actually increases wing chord, as does the extension of the leading edge device. Collectively, they increase wing area by approximately 1/3, thus providing maximum performance in the low-speed regions. With the leading edge flaps and trailing edge flaps retracted, the swept wing permits cruise speeds about 10% faster than today's jet transports. The landing gear of the 747 possesses high flotation qualities. It imposes minimum stress on runway surfaces. The gear presents an extremely large contact envelope. The 18 wheels distribute the weight of the airplane over an extensive area, thus minimizing localized high stresses. Now let's take a trip to the cockpit. A tremendous amount of engineering effort was devoted to cockpit design, because that area is the command post of the whole system. Working closely with our customers, the cockpit was designed for comfort and crew effectiveness. For example, the integrated electronic flight control panel is directly accessible to the pilots. This unit provides the necessary control for hands-off flight, not only during cruise, but also can control the 747 during the initial letdown through the ILS approach and down to an automatic landing. The inertial navigation system was developed by AC Electronics. It is one of the finer features incorporated in the 747. For the sake of brevity, we call it the INS. Located at the pilot's fingertips, the INS can be programmed before the start of a flight. Waypoints and destination are inserted, and the internal computer is ready to navigate. Gyro-stabilized platforms, acceleration sensing units, and command actuators furnish inputs to the automatic pilot. The 747 is therefore navigated and guided electronically from point to point. One commodity that Boeing has available is experience. Since 1916, when the first Boeing airplane was flown, to the present time, we have had the finest engineering talent available. The 747 reflects this vast storehouse of professional skill and ability in a manner better than may be stated in words. Because of the magnitude of the 747 project, it was necessary for Boeing to look to industry for assistance, and we subcontracted 47.5% of the entire program. Let's look at a few of the major sub-assemblies that represent nearly half of the 747 program. The NORAIR division of Northrop builds sections 42, 46, and the upper lobe of 44 between the nose and tail. They constructed special cathedral jigs, some 4 stories tall, for assembling their 153-foot section of the passenger cabin. Ling Temco Vought accomplished in aerospace industry first by a new cold bonding process. LTV fabricated the world's largest pressure bulkhead for the 747. The Cleveland Pneumatic Tool Company, builders of the huge landing gear, spent over $14 million for a new facility and for developing the largest drop test tower in the world. Control surfaces for the wing structure are produced by the Republic Aviation Division of Fairchild-Hiller. Aileron spars, Kruger flaps, spoilers, and inboard and outboard ailerons all come from this facility. Wing stubs and landing gear doors are the products of Goodyear from their Litchfield Park plant in the heart of Arizona. North American Rockwell builds the 1350 bulkhead, which is part of lower lobe section 44, a key assembly point, for here the fuselage and wing are mated. Additionally, they build the fixed leading edge of the 747 wing. Engine nacelles and struts were designed jointly by Boeing and the Rohr Corporation. The Wichita division of Boeing produces the 747 nose section, and even though this is a Boeing facility, they faced the same challenges as all subcontractors in the program. Everything had to fit with every other mating part produced by subcontractors thousands of miles apart. As the fabricated parts arrived in Everett, the giant task of assembly began. Someone called the 747 group the Incredibles. We think it's a good name. Certainly this was no ordinary job, even in our highly sophisticated age of automation and computerization. No, it was just plain people with dedication and skill, who were really responsible for the 747. And on September the 30th, 1968, the 747 was rolled out of the factory. It was a momentous day for the Boeing Company and for the aviation industry. Following rollout ceremonies, the airplane was quickly readied for the initial engineering inspection. This was a grueling shakedown and was participated in by engineering, manufacturing, safety, and the project pilot and his flight crew. Every part, component, and system had to be examined, operated, and tested. One 747 design feature of fundamental importance is system redundancy. 3 separate systems are provided to operate the flight controls. The triple-slotted flaps, high-speed ailerons, spoilers, leading-edge devices, low-speed ailerons, rudder, and elevators all have multiple systems to ensure proper functioning under all conditions. And during the inspection, all were examined with meticulous care and exercised repeatedly. Then the airplane was declared ready for flight test and released by manufacturing. Soon the first taxi tests were conducted, and they proved entirely satisfactory. The airplane proved to be just as maneuverable as designed. During the high-speed taxi runs, on an extremely wet runway, wheel brakes and thrust reversers operated exactly as planned. And on February the 9th, 1969, the 747 was cleared for its first flight. This was another great day for Boeing and for aviation, because this first SuperJet transport of the future had made that future a reality. Perhaps more important, the airplane performed beautifully, or as the test crew reported, it's a pilot's dream. The first landing fulfilled every expectation of the designers and builders and the test crew. Now the hard work had to begin. Flight testing is a demanding chore. Every flight characteristic had to be explored and checked and proven and demonstrated to the various aviation regulatory authorities. Extensive instrumentation was built specifically for the 5 747 test airplanes, and onboard computers and recorders measured and stored millions of data bits. Water ballast tanks were located in a manner that permitted the test crews to alter both weight and center of gravity in flight. Hundreds of stalls had to be performed under every possible attitude, power setting, and exterior configuration. Naturally, you will never experience takeoffs of this nature, but for test purposes, high angle of attack takeoffs under various load conditions and varying power settings established the stability and low-speed performance capabilities of the 747. To verify the shimmy-free characteristics of the nose wheel and main gear, high-speed approaches and touchdowns had to be made under many different load conditions. Onboard computers and electronic sensing devices, coupled with integrated electronic flight control systems, provide the capability to land the 747 automatically and with unerring accuracy. We have now entered a new age of manned flight. The Boeing 747 is the first of the giants, the pace setter of the new era. If you have any questions about the 747, its system, its performance, or its capabilities, specialists are available for consultation at your convenience.